Okay, good morning. So let us continue the lesson that we started last time. So if you remember, we started talking about a very important concept, notion in mathematics called the derivative of a function. Let me just remind you quickly what we did. We were supposed to find, let us talk from Leibniz point of view first. So we had this coordinate system. Yes? Mm-hmm. So let us have x and y, and then we have, for example, a curve here for a given function f of x, and then you have a point here on this curve somewhere with x coordinate, let us call it a, and then at this point we wanted to draw a tangent line to this graph, and then Leibniz wanted to actually find an equation for this tangent line. Yes? So we wanted to find an equation for this tangent line, and then we saw in the previous session that of course we don't have to be able to find an equation for any line. One way is to use the 1-point formula. So in that formula we need 1 point on that line. Whatever it is, it doesn't matter. And then we need to find the slope of the tangent line. Yes. And then for this point, we don't have any problems here. So I usually call it T, the point of tangency. Its x coordinate is of course given to you. And then you put this number into the given function. You get a number. That number is the y coordinate of that. So it means that you already know A, you already know f of a, so you don't have any problems with that. And then you are supposed to find the k value, so let me call it k of tangent. And I wanted to motivate you in the previous lesson that k of t, the definition who Leibniz actually made for k of t, is plausible. That was my only goal in the previous lesson. So I motivated you about this formula. And then I try to make it plausible for you that this number is a good candidate for what we are supposed to call the slope of this line. Yes? And then if I can calculate that limit, and then I can have the 1-point formula. Do you remember? 1-point formula was this, the k value x minus x node. So instead of y node, I put the y coordinate of the point of tangency. Instead of k value, I put that k sub t, which should be calculated using that formula, and then x minus x node is a, and this would be an equation for the tangent line that I am supposed to find. Yes? That was more or less a very crash review about what we did before. Okay, and then I talked a little bit about Newtonian perspective. I told you that Newton was interested in calculating the instantaneous velocity of a moving particle, and then I told you that the method Newton used at the end was completely similar to the method that Leibniz used for a totally different problem. Yes? So they were great scientists. One of them was working on mathematics problem, the other one was a physics problem, but both of them were guided actually towards the same kind of limiting process for being able to solve their problems. And from these two perspectives, I wanted to motivate you that at least this limit that you see here is important, and because we were trying to solve two completely different problems from different categories, but both of them forced us to learn something about this particular limit. Whenever something like this happens, it means that probably this concept in our universe is an important concept. So, and if it is in mathematics, mathematicians think in this way. Okay, if something becomes important for them, what they do, they will give it a name and then give it a symbol probably, and try to explore as much as they can about that. Yes? Or of course for physicists might be, so for mathematicians you can write any sort of functions, but might be physicists are not that interested for all possible imaginable functions. They might be interested in those functions that appears in some kind of applications in physics, yes? But for mathematicians, no, that they just want to explore what is behind this concept more and more from just mathematical point of view, okay? So, this is why they give it a name, and the name of this is called, this limit is called the derivative of f at a, and it is denoted by this symbol they have chosen, f prime of a. Yes? Okay, but now I want to write it formally. So let me just write the definition of the derivative formally. So definition, I would say that let f be a function with domain df, capital D sub f. So do you remember, every function associated to every function, you have a domain, yes? So for example, if I ask you what is the domain of this function f of x equals to x squared, so what, by the way, about the functions, please try to think it in this way. Function is a box or is a machine, an operator, so that it takes an input from you, you call it x, and it gives you an output. So then this is called f of x. This is a very nice diagram that you need to have in mind when you are dealing with functions. So function is just a, I don't know, a machine, an apparatus, so that you send some x in it and it acts something on that input, gives you something back, and that is called f of x. So some people, I don't know, even some books, they say the function f of x. It's not a good word, because the function is the product of the machine, not the machine itself. But the function is the machine itself. So is that understandable? That's, you have to differentiate between the function and its product, what it is produced, yes? So f of x is the outcome of the machine, but the machine itself is the function, yes? Okay. So, and you know that there are some limitations about the inputs. Okay, so for example, if I have this function on the board, this tells me that I am sending x into this machine, and what it returns back is x squared. Yes, do I have any kind of limitation for choosing this number? For this function, no. Whatever I choose as a number here, f will be able to operate on it, and it will give you x squared. But if I have another function like this, for example, yes, something like that, then of course I have some limitations. If I send 5 in, it gives me back square root of 5 instantaneously, yes, but instantly. But if I send -2 here, then I will get an error message. That's exactly like your calculator, yes? So if I ask you what is the domain of this function, you will say the domain of this function is the set of all possible real numbers. But if I ask you what is the domain of this function, you would say that if you want to write it properly, you have to write it with curly brackets, because the domain technically is a set, is a collection, and in mathematics, when you want to denote a collection or a set, you have to respect and use curly brackets, nothing more, okay? And then how do you express it? If you really want to write it, it becomes x all x's coming from the set of real numbers. You remember this means belongs to, but not all of them, such that x is greater than or equal to 0. Yes? So that is the domain of this function g. Yes?
Can't you also use imaginary numbers in the first one? Because if x is...
No. I am not talking about complex functions at all. Yes?
Okay.
Everything we want, this is called real analysis. You can also have derivatives, integrals, and everything in the realm of complex numbers. But that is beyond the scope of this lesson. You will study much more about complex numbers in Math 5, but not complex functions. Complex functions, completely different category. It's harder.
Is it in college or university?
It depends. For example, if you go to electrical engineering or something, even if you want to become an engineer, you will study a lot of them. But usually you need to be a physicist or mathematician to talk about complex analysis rigorously. Yes. But complex analysis is super important for engineering or telecommunications and things like that. Yes, using the, I don't know what's the name in English, but anyway. Okay, so here, what I am telling you that it's not that important for you. I don't want to be disturbed by this notion, but if I want to write the definition precisely, I have to introduce you the domain of the function, and you understand what is the domain of the function, yes? So let f be a function with domain f, and let a be a number in the domain. So I hope that you don't have any problems reading this. It means a belongs to the domain of the function, yes? The derivative, this is the word we are going to define. The derivative of f at a, some books write x equals to a, that's also correct, of f at a is denoted by f prime of a, and it is defined as follows. So we say that f prime of a is equal, exactly that limit. So you already know this becomes f of a plus h minus f of a divided by h. H goes to 0. I write a sentence here. You still don't appreciate, you cannot probably appreciate that because I haven't talked about limits systematically, but I will come back to this later. Okay, provided that this limit exists. So this sentence, we will come back to it later, but don't worry for the time being about this sentence. Okay, and hopefully everyone respect the soul of Newton and Leibniz and memorize that, even though you get this formula in the formula sheet, but it really deserves that. I think this changed the human history from scientific point of view, yes? Okay, so here, if I compare this one with what we had before, this remark is very important. I want you to have this always in the back of your head now. So remark, very important. Of course, let me just draw some diagram for you that is easier to remember. So the content of the remark, I write it here in this part of the board. So if I have this, x and y, and then if I have this, y equals to f of x, yes? And then you have a point here whose x coordinate is a, and then you draw a tangent line here. I make it short, But of course, you know that tangent line continues from both sides forever, yes? That's the meaning of a line. And then, if I call the k value kt, this is important to remember. The k value of the tangent is equal to f prime of a. Okay, so let me clean this with open. So the k value for the tangent line is the derivative of the function calculated at a. What is a? A is the x coordinate of the point of tangency t. Yes. So if you want to find the k value for a tangent line, which is tangent to the graph at some point, you have to calculate the derivative of that function at which point, at which number, the number which represents the x coordinate of the point of tangency. So be careful about that. So try to repeat this for yourself so that it goes to your brain. Yes, that's very important. It's very easy, but I want you to learn about it. For example, if I ask you in this picture, if I ask you in this picture, what is the derivative of the function? So let me call this one f of x, for example. And if I ask you, what is the derivative of this function at point A? Of course, you might not be able to answer it precisely, but it means that if I draw this tangent line and I can calculate the slope of this, it gives me a number. That number is exactly to the number that I am asking you. Yes? So in this case, do you think, even though I cannot measure this slope precisely, but do you think that this turns out to be a positive number or a negative number? Positive? It's a positive number because you remember any line in this direction has a positive slope, and then the derivative is the slope, so it should be positive. For example, if I take this point to be B, and I ask you the same question, f prime at this point is positive or negative? Negative. It is negative because now the tangent line is this one and this slope here. For example, if I can precisely point to that, and if I ask you what is the derivative here, what do you think? 0. Yeah, because the tangent line, if I am correct, it becomes horizontal and the slope is 0. So here you can find it exactly, but here you can just say it is positive, here you can just say it is negative. Yes? Is that understandable? So you should have a good connection between algebra, which calculates the exact value for you, and the geometry, yes, behind it. Okay, so today let us try to practice a little bit about the notion of the derivative. Okay, so let me give you some examples. Example, where is this one? Okay, I can use my own examples, but there are some examples like this in the book. Okay, so use the definition of the derivative to determine the derivatives of the following functions at given points. So for example, let me start with a simple example. So I give you f of x equals to, for example, x squared plus 3 and then I ask you to calculate the point A that I give it to you is, for example, 5. Okay, so we want to calculate the derivative of f, which is given, at this point, which is also given. That's a standard problem, yes? And then let me underline this. When we progress here in this topic, you will find a better way to do this. But still, in the exam, I might ask you about this definition. So in the future, we will have a very, very simple way of doing it. But if in the exam you see use the definition, even if you know the simple way and you can calculate and find the answer exactly, you will not get any points if you do not respect this. In Cambridge A level, they say use the first principles. And that is the meaning of use the definition. That's the same thing. Okay? Okay, so here, let me change my color. This will be the solution. So what is demanded in this problem? In this problem, let me, by the way, write the formula here for this lesson. So we don't need to write it all the time. So the limit f of what? A plus h minus f of a divided by h, and h goes to 0. So I will use this formula over and over again in this lesson. And I told you that this is also given in the formula sheet, but try to memorize that. So in this problem, what I am asked to do, I am asked to calculate f prime at number 5. Yes? So this becomes the limit. In the given formula, I have to replace a with 5 everywhere. Yes? So this becomes the limit of f. Instead of a, I put 5. But instead of h, I have to respect and put h. And then minus f of 5 divided by h. And h goes to 0. And then you're supposed to calculate this. Okay? It is very simple, but make sure that you are not confused. So there is some copy and paste parts. Yes? So these are the copy and paste parts. Don't be lazy to write this limit until the very, very last step. Okay, and then what is the meaning of f? I told you that if you want to understand a function is like a machine. You send in x, it gives you what back? In this case, it squares the input, adds 3 to it, and gives it back to you. Now here you are sending, so if the input is x, this is the way that the function acts. Now the input, read it for me. What is the input in this case? What is the input that you see?
5 plus h.
5 plus h. So the function will do exactly the same thing for this new input. Meaning that it squares it and then adds 3 to it. In other words, you should go to your function, replace every appearance of x with what is given here. So I take every x from my function away and replace it with 5 plus h. That is the x. And then f of 5 is exactly the same thing. So you send 5 in, it's 5 squared plus 3 is what? 28. So it becomes minus 28. And then you have to simplify this. From now on is the chapter 1 lesson. So you should be able to simplify this. And usually this is much simpler than the expressions appear in the first chapter. Yes, this is very, very simple. So what I have to do, but I have to respect the punctuation rules. I have to copy and paste this all the time. Yes, until the very last step. So I square it, it becomes 25. 2 times the first one times the second one. The second one squared. And then plus 3 minus 28. And then you can see that 25 plus 3 is 28. Minus 28 is totally gone. And then what is left for me is 10h plus h squared. And then divided by h, h goes to 0. And then this becomes the limit, and then you factor an h out, you have 10 plus h divided by h, h goes to 0. because I hope that you agree that I am not allowed to simplify this h with that h in this form. I'm not allowed to simplify this h with that h squared in this form. But when I factor it out, then I am allowed to do that, yes? So this h now is safely removed. By the way, why I should be able to do that? I can do that. It means that I am dividing the numerator and the denominator by h. But why I can do that? Because I told you yesterday, the previous session, that when h goes to 0, it means that h is very close to 0. But one important point is that h is not equal to 0. And when h is not equal to 0, even though it is very, very small, no problems will happen for me. I can safely remove it, okay? And then what is left for me is the limit of 10 plus h goes to 0, yes? And then, what is the answer? I don't have any problems with putting h equal to 0 here. It becomes 10. Yes. So the derivative, so how do you say that? You say that the derivative of my function at 0.5 or at 5 is equal to 10. Yes? And if someone asks you, what is the geometrical meaning of this number? If I want to have a sense of what I have calculated, what do you say in answer? Yes, Ali?
The key value of tangent.
No, please completely, you are right, that's correct, but I want you to tell me exactly what to do. For example, you can tell to that person, go to GeoGebra and draw the graph of this function, and then find a point on the graph whose x-coordinate is 5. Ask GeoGebra to draw the tangent line as we did last time, and then the line that you get has this slope. Okay, so that is the way that you have to think about it. Yes? Is that clear? Okay, there is a word I haven't seen in Swedish books, but this is the way that I use it in the exams and everything, and English books. If the derivative at a point exists, of course 10 exists, we say that f is differentiable at 5. This word I want you to learn, okay? I will use it, because this is the correct way of expressing that. So here, let me write this. So this word, I will use it in exam, but I haven't seen an equivalent word. The words that Swedes use is coming from this derivative and things like that, but I want you to remember this word. If f prime of a exists, I hope that you are not afraid from the word exist. Exist means that if you can calculate it, it turns out to be a number. Yes? Let me give you some ideas about. So, for example, if I ask you to calculate this limit, and I ask you h goes to 0, okay? This limit, we will come back to and study it in more detail, but sometimes limits do not exist. One of them is this case. If I ask you, I am making x very small, what is the number that 1 over x is getting close to? It is not close. So for example, if you draw a table for yourself, x and then 1 over x, let me make x small. For example, 0.1. Then what will happen if I put it in my function? It becomes 1 over 0.1, which becomes 10. And if I make it smaller, because I'm supposed to get closer to 0, then what happens if I put it here? It becomes 100. Yes? And if I make it even smaller, it becomes 1,000. So then you see that even though I am getting close to 0, but these numbers are not approaching to a particular number. Yes? They are just growing infinitely big. In that case, this limit does not exist. Because there is not a number, even though I am approaching to my target, 0, but these numbers are not approaching to a particular number. In that case, we say the limit does not exist. So that is why you don't need to be worried about this concept yet. all the derivatives will work because the derivative is defined using the limit notion. We should have always this, we have to be careful that sometimes the limit does not exist. And in that case, the derivative does not exist. And the derivative is not exist, so this is why I always emphasize, if f prime of a exists, then f is said to be, this word I want you to learn, differentiable at x equals to a or simply at a. It doesn't matter. This is the word that I want you to learn. So by this calculation, can I say that f is differentiable at 5? Yes or no? Yes, because the derivative of f at 5 exists and it is 10. So this function f at 5 is differentiable. Can I immediately conclude about differentiability of f at 7? If I ask you, is f differentiable? We learned that f is differentiable at 5 because when I calculated f prime of 5, it exists and it is equal to 10. Now, can I ask you, is f differentiable at 7? I can ask you, but you cannot immediately answer. You have to do the whole process once more for 7. And if it turns out that this becomes a number again at the end, then you would say, yes, it is differentiable, otherwise it is not differentiable. Yes? And that's the boring part. So if I calculate so heavily, if I change the number, I have to redo it from scratch again. So then we have to find a way to get rid of redoing all these things all over again. Yes?
How would it look like if we don't find a number that exists?
Yeah, for example, that's a good question. I will come probably at some point to it. So it might happen that you have a graph which is broken. If you have a graph which is, this is discontinuous.
Not well behaved.
Not well behaved, exactly. The way, the word that we learned before. Do you remember exactly that word? I talked about well-behaved functions. The well-behaved functions are the functions who are continuous and, do you remember? Yes?
Like no sharp.
No sharp points. Exactly. So if you draw the absolute value, the graph of the absolute value is this one. If you learn how to do a little bit more advanced limits, then you realize that this function is not differentiable at this sharp point. So it means that if you do the same thing for this function and you want to calculate the limit, you realize, if you know the topic of the limits good, you realize that this limit does not exist. But these are the points that if you want, visually it is very simple. Sharp points, not differentiable. Discontinuous points, not differentiable. There is also another category that you might be able to understand it right now. Okay, can you guess? There are 3 categories, by the way. That was a good question. Thank you, Gustav. So we have 3 categories. Sharp points, not differentiable. Discontinuity, not differentiable. But there is something that you can guess right now. I think you can guess, or at least you can think about it. There is a 3rd category of points. By looking at the graph, you immediately realize that that is also not differentiable. The function is not differentiable at that point. Can you see when? Yes?
For like straight lines.
No, horizontal lines, no problems, yes. Because the derivative is the 0 value. Yes? Yes? Vertical lines. Okay, but what type? Not just vertical lines. When vertical lines matter. So if I have the graph of a function like this, I cannot draw it precisely, but I can give you a feeling. So assume that this point is A. Okay, and if I ask you to draw the tangent line to this graph at point A, I hope that you agree with me. This is a sensible way of saying that this green line is tangent to this graph. But the tangent is the slope of the the derivative is the slope of the tangent line. But what is the slope of this tangent line?
0?
No. Vertical lines.
1.
No.
X equals
No. Not defined.
45.
No. Horizontal lines, 0. Inclined in this direction, from your perspective, positive slope. Negative slope, undefined slope. Yes? So this, if I ask you what is the slope of this, it is undefined. And on the other hand, derivative points to the slope of the tangent line. But the tangent line doesn't have any slope, so this is... So 3 points. If you want to understand 3 categories of points. Discontinuity, sharp points, at points where the tangent is vertical. Yes? These are 3 points that by just looking at the graph, you immediately realize that the function is not differentiable at that particular point. Is the function differentiable at this point? Yes, why? Because I draw the tangent line here, and that is good. That is possible. Yes, it's not a vertical one. Is it differentiable at this point? Yes. Is the derivative here positive or negative? Positive, because it is tilted in that way. The derivative here is positive or negative? Positive, yes? So that was a good question. Now you understand that sometimes the derivative does not exist. At least you understand it from geometrical point of view. Okay, but of course if you want to understand it from a rigorous point of view, it needs a little bit time. And I think it is not part of your lesson. It is mentioned for interested students. Okay. Okay, let me give you one more example here. So I would write this f of, let me change the letter for the function as well to get used to that. Yeah, okay, g of x equals to 2x squared minus 3x plus 5. And let me put the point A to be minus 1. For example, in the exam, I can ask you, is this function differentiable at that point? And then if you want to say yes or no, you have to do the process and calculate. If it turns out to be a number, then you would say yes, it is differentiable, otherwise it is not. Okay, now can you help me what I'm supposed to do? I want to calculate, if possible, the derivative of g at this given number. So what I want to do, I want to calculate g prime at minus 1. How should I read it? The derivative of g at minus 1. So what should I do? I would say that this is the limit. Of course, the name of my function is no longer f, it is g. So in the formula, I will put g for f. And I have to replace a with this given value. So it's minus 1 plus h minus g of minus 1. And then I have this divided by h goes to 0. Yes? I have to calculate this, and if it turns out to be a number, that number is the derivative. Okay, so how should I continue? So this the limit, h goes to 0, these copy and paste parts, you have to do them. Okay, so what is the meaning of g of minus 1 plus h? Don't get confused. You need to go to your function, replace every input that appears there with the new input. Yes? So what happens? It becomes 2 minus 1 plus h squared minus 3 times x, it is minus 3 times minus 1 plus h, and then I have positive 5. I would recommend you to do it in your head, or you do it in a scratch paper instead of writing it so much. Okay, so what is g of minus 1? I have to go and replace x with minus 1. You can do it in your head. So this becomes 1 times 2 is 2. Minus 1 times minus 3 is positive 3, and positive 5. So what's the answer? 10. Yes? So just write minus 10. Be careful about this minus. If it was minus 10, then you have an extra minus sign here, then it becomes positive. So be careful about those things. And the next thing is just very simple. You just need to expand that. Yes? So how should I do? So the limit, so be careful. Which one has the priority? I am not allowed to multiply 2 in. I have to raise it to power 2 and then multiply it by 2. So let us just do that. So I put 2 here. The first one to the 2, 2 times the first one times the second one to the 2. And then I can multiply minus 3 in. It becomes positive 3 minus 3h. Positive 5 minus 10 is minus 5. This is minus 5. Okay, and then divided by h. So you have to do it patiently. This is lengthy, but sooner or later we will find a better way to do that. So it becomes the limit. I multiply 2 inside, so it becomes 2 minus 4h plus 2h squared. And then you have a 3 minus 5 is minus 2 minus 3h. And then divided by h goes to 0. So this is what? This is minus 2. Don't get confused. This is not c. Okay, so so let us continue here. This is simple algebra. So 2, by the way, 2 and minus 2 are totally gone. I have minus 4h, minus 3h, and I have positive 2h squared. So let me write them in order. The copy and paste parts. So what happens? It is 2h squared minus 7h. Okay, but I'm not allowed to simplify h, you know that, unless I factor the numerator. So I factor h out. Then what happens? H and h are safely cancelled. I want you to understand why I'm allowed to safely cancel that, because this symbol means h is not equal to 0, even though it is very close to 0. And then what is left is the final step. It's 2h minus 7, and h goes to 0. So the answer is minus 7. So here, the answer is g prime of minus 1 is equal to minus 7. And I think, don't get confused, there is no relation in general between the sign of the number that I put in and the number. It was a coincidence. I started with 5, which was positive. If you remember, I got positive 10. And here I started with negative 1, and I got the negative 7. That was just a coincidence, yes? You can have 4 possibilities.
Babak,
Yes?
let's say you end up with a lim of the 400h minus 7.
400h minus 7, yes?
Yes. Then that h would be almost significant, wouldn't it?
No. That's a very good question again. I told you that the notion of limit is a little bit complicated. So this is why they skip from it. So even if I multiply it by 1 trillion
Okay.
times h, it becomes 0.
Almost
Yes.
0, but sure.
Yes.
Yeah.
Almost negligible. You are saying that, yes, of course, that is a very good question, but I will not be able to answer it properly here. But what I would say is that, first of all, if you want to get the points, this is my advice. If you put h equal to 0 there and no problems happen, that is your answer. So it doesn't matter if this is close to 0 or it is exactly 0.
Sure.
Because my point is not to find the exact value for this, because I'm talking about the limit, so it means that I want to find to which number this is getting closer and closer if I continue making it smaller and smaller, yes? Of course, you are right. If I have 400h minus 7, if I want to list it and I put h here, if I put with 0.1, which of course is close to 0, if you don't mind, let me make it easier for me to calculate in my head. Let me make it 1000. Yes. And of course, if I put this one here, 1000, it becomes what? 100 minus 7, which is 93. Okay? But then I shouldn't stop here. I have to make it a smaller and a smaller and a smaller, yes? So continues forever, more or less. So 0.01, what is the answer? If I multiply it by 1000, it becomes 10, yes? And then this one is 3. Yes? And then if I make it even smaller, this becomes 1 minus 7. It becomes minus 6.
Sure.
And if I make it even smaller, what happens here? It becomes 0.5, it becomes minus 6.9.
Yeah.
And if I make it even smaller, it becomes how much? Minus 6.99. And now you see that something is happening. So you see the difference was quite big here. From 93 suddenly I jumped to 3. And the next number was minus 6. But this is no longer happening like that. So it seems that if I want to continue, 4, 5, 1, if I have done it right, it becomes, I think, this one. And now you have the feeling, here I am doing the same thing. I am sending them very close to 0. Now if I ask you, do you think these values are stable somehow at the end?
Yeah.
Yeah, it is stable. Around which number?
7.
Minus 7. No, minus 7. And that's exactly what you get here.
Yeah.
So that's what, even if I make it 100 trillions, of course, this process will take longer, but finally it will stabilize at exactly minus 7.
So
And that is exactly what we call as the limit of a function.
the coefficient of h is negligible.
Yes, when I say negligible, it means that you can think in this way. It's smaller than any positive number that you can imagine.
Okay.
So even smaller than a number that if it is multiplied by 1 trillion, it is still negligible.
Sure.
Yes?
Yeah.
But of course you have to go further. But at the end, you will be stable at some point. If you are stable at some point, that point is called the limit. But sometimes you are not stable at that point. You don't need to be worried, so you don't need to make it complicated. For example, here. If I start giving n, of course here, but this is not a good example. But if I give you, for example, 1 over x, as I mentioned, if I start making it smaller, I can calculate the numbers, but you can have the feeling that they are not gathering around one particular point. They are actually making it bigger. So this means that there is no way that there is a limit for this function. Yes? Okay. But that was a very relevant and good question. Thank you. Yes.
So, according to that, I was thinking, okay, we have 2h minus 7, so then I have to make h alone, so divide it by 2, but we don't need to do it because no matter what h is, it is really, really small.
Yes,
Like
exactly.
The coefficient of h, it doesn't
Yeah,
really
if you
matter.
want to discuss about these things, that there is a space for that, but that's not part of your lesson. I want you to understand at least, this is something very understandable. These are just numbers. But if you don't, what I tell you for calculating the limits, what I tell you is that at the end, if you don't have any problems with replacing the h value with the given number 0, that is your number. So you really don't need to be worried, but all the concerns that you actually brought up are relevant. So we need to address them somehow. But this is the way that at the high school level you need to understand, yes? So it means that if I start approaching this, after I am sufficiently close, that is the word, okay? I don't want to talk about those things. If I make h sufficiently close to 0,
Sure.
then this function becomes arbitrarily close to the number minus 7. So I can make these values close to minus 7 as much as I desire, but there is one condition. I have to fine-tune h better. Yes? By better it means that making it more small.
It takes longer.
Yes,
to
yeah,
calculate.
yeah. But if at the end you are convinced that they are gathering very close to one particular point, it means that the calculation becomes stable, then that number that these numbers are getting close is your limit. Yeah. Okay, any questions here? Okay. Now, assume that I am insane, or crazy, or mathematician, or whatever. You process this and calculate for me g prime of -1, and you got -7. And I say that, sorry, I didn't mean -1, I meant 0. There is no way for you. You have to redo all the calculations. Because what you are supposed to do, you have to replace -1 with 0. But you need to know what will happen. So you have to do the calculation again, and then because I'm mentally a little bit sick, when you would finish, I said that I'm really sorry, mentally sick but polite, yes? I would say, oh, sorry, I meant, for example, a equals to 2. And then you have to redo it again. And then if I continue to be crazy like that, how do you feel? And how do you solve the problem? Your problem now here, because I'm your teacher, you have to respect me, okay? So then you have to obey me, yes, and somehow, And then what happens if I start changing these numbers over and over again? Mm-hmm. On the one hand, you want to respect me, you want to solve my problem. On the other hand, you like yourself more than me. You're lazy, yes? So what do? How do you solve the problem then?
You do it again?
Okay, that is very kind of you, but
Yes.
is there any better way to do that?
I believe so.
Yes? What is that?
No idea.
No, you should have an idea. It is not that hard. Yes?
What if we found some sort of general derivative?
Exactly. So that is the end of the story, yes? So you say that, okay, this Bobak will continue bothering me by changing his numbers. So let me solve the problem once for not a given number, algebraically for any number.
Okay.
Yes? So in that case, this is very important. So in that case, you would say that, let me start with the simpler one. So I don't want to distract you. Let me start from here. So I gave you this function, f of x is equal to x squared plus 3, and I gave you this number 5. Okay? And then if you remember, we calculate and we found what? F prime at that point, if I remember, was 10. That was what I got. Now, if I change my opinion from 5 to any number, you have to redo it again, but you do it in a much better way. You would say that, let me write this formula for any x. Yes, not just for a. For any x that Bobak will provide for me later. Yes? So this becomes the limit of f. What should I write? Instead of a, I have what? X plus h minus f of x divided by h goes to 0. So you will tell to yourself that if I can solve this problem not for a given number like 5 or 7 or whatever, just for a typical number like x, then I will be done. I don't need to redo it over and over again. Of course, it becomes a little bit harder because now you have to work with two variables, apparently, and two parameters, x and h. But of course, which one is the variable here?
H.
H, because x is something that I give to you and then you have to work with it. But h, you can fine tune it. You have to change the values of h to making it smaller and smaller. So your real variable is h, even though you have another letter involved. Yes? Okay, now can you help me to do this for this problem? It is very simple, you see. F of x plus h. Can you tell me what should I write instead of the first term, f of x plus h? What should I do?
X plus h with the power of 2 plus 3.
3, yes. So I have to go and take the input out and replace it with the new input. There is only one place that you can see the input, so that's the only one. So it becomes x plus what? h to the power of 2 plus 3 minus, this is, you have to be careful, minus f of x, but f of x is this one. So I have to open a pair of brackets around that, or you have to do it mentally, but you have to be careful. This minus sign is both for here and there. Overall divided by h goes to 0. Of course, you see the structure is a little bit more complicated than the structure that we had for f prime of 5, but it will be worth it if you have a math teacher, yes? So then what you do, you will go continue. You say that I square it, it becomes x squared, 2 times the first one times the second one, 2xh, and then h squared. And then I have positive 3, and then I multiply this negative sign in, it becomes negative x squared, negative 3. Yes, h goes to 0. And then what happens, this is easy to see, it's cancelled. And by the way, this is also easy to see, it's cancelled. And then what is left for me is the limit of 2xh plus h squared. This is the only one left, only ones left. And then I have h goes to 0. But you see that I cannot simplify this h with that h, I cannot simplify with that. So I have to factor it out if possible. Here it is possible. Divided by h goes to 0, and then let me not repeat these things anymore. So this I can cancel, and this becomes the limit of 2x plus h goes to 0. Can you tell me what the answer is now? What is that?
2x.
2x. So the answer is 2x. And then you don't reveal this to me, but you have it in your scratch paper. Okay? Now, if I have 5 in mind, what will be the answer? 10. So you just replace it with 10.
Yes.
And then if I say that, okay, sorry, I made a mistake, x should be 0. You pretend that you are solving this long process, but you know what to do. You put 0 here, the answer is after 2 or 3 minutes, you say, oh my God, I got your answer, that is 0. Yes? And then f prime of 5, so it is 2 times 5 is 10. And that is exactly the number that I got with particular calculations here. If I ask you what is f prime of 7, what is the answer? 2 times 7 is 14. And you can immediately answer all my questions, yes? Yes or no?
Yes.
Okay. And that is the way actually mathematicians started to think. Okay, with this, I hope that I was able to convince you that this is a boring process sometimes. And not just boring. It turns out that sometimes if I make the function complicated, it is even impossible to calculate that limit. Is that clear? So now we want to somehow get rid of this very long process. This should be in the back of your head. But I want to give you a little bit of time. I want to do the same thing once yourself for this function. Okay, this becomes quite long, but it's worth it at the end, because then you don't need to calculate it over and over again. Okay, but before doing that, I want you to understand what we are doing. This function, if I want to draw a diagram for this function, what was that? This was if I send in x, what do I get out? X squared plus 3. Yes? Now, what is happening, by the way? This function, I got another function. Yes? The derivative function. Now, if I send x to the derivative function, what do I get?
X, 2x.
No? Be careful.
Yeah, 2x.
2x.
Yes.
So you see, this function is a new function derived from another function. So that's why it's called derivative. Yes? So it means that this differentiation is a process of finding a new function from an old function by doing very special thing like calculating this limit. So I want you to have this picture in mind. That's a very good diagram. So if I have a function, if the original function that I started with takes x from me, gives x squared plus 3 back to me. But the derivative function takes x from me, just multiply it by 2 and give it back to me. This is also a very good way of imagining things. Okay? Now, I want to have the same question for you, but for g. So let me just draw the diagram here for you. So if I ask you what is the function g, if you want to imagine it, g is x. When I send it to g, what do I get as the output? It is on the board. It squares it, multiplies it by 2, multiply it by 3, and then subtract them, and then add 5 to it. Yes? Now my question for you is, using this long process, do this one for me and fill up this question mark. Yes? I want to give time. I know, I agree with you, this is boring. By the way, it's not boring, it's really fun. Yes? I don't know why I call it boring, because I enjoy it
It's very fun.
whenever I do it, so it doesn't
It's
matter.
tedious.
I'm just looking at it from your perspective somehow. Yeah, I don't know. When I say it's boring, you might say that, okay, Babak knows also boring, but he's doing it, let me do it as well. Yeah, something like that. But I'm just lying. I don't think it's boring, it's really interesting. Okay? So, yeah, I will pause the recording, give you 5 or a little bit more. I want you to finalize this problem for me. More or less everyone. Okay, so I will give you a little bit more time. So if you can do it yourself, then it means that you are on the right track. Okay, let us check some of your answers with a different color here. So, I don't know, any volunteer to say the answer? Yes?
4x minus 3.
4x minus 3. How many of you agrees with that one? Yes, that's the correct answer. The reason that I immediately understand that it's the correct answer, not because I'm calculating it in this long way.
Wait, isn't
I
it
will-
minus 4x minus 3?
No, 4x minus 3. Okay? I will tell you later, definitely it should be a matter of seconds if you
there
can
you
do this later. You have to be able to learn that. But for the time being, let us not jump forward, so let us just do it step by step. So that's the correct answer. So whatever, if you got this, it means that you really understood everything so far, and if you have done some minor mistakes, but still you understand, you have to redo it again. Okay, so what I do, I would write it as g prime of x. So let me repeat this again. So x plus h, g of x plus h means go to your function, original function, replace every input appears there by this x plus h. So there are 2 places that the input appears here, yes? So I replace them with x plus h, but I have to be careful about how to write them properly, yes? I have to put a pair of brackets here, and a pair of brackets here, and then of course I have 5. And then I have minus g of x. If you write it like that, that becomes wrong. So what is the correct way of writing it? I have to put it in a pair of brackets.
Yes.
Or if you want to do it mentally, that's okay, but you have to be careful that you have to multiply this negative sign here, here, and there. And then divide it by h. h goes to 0. Okay, and then this part is just simple algebra. So I have to keep 2 here. I raise it to power 2. It becomes x squared, 2 times the first one times the second one. The second one is squared. And then I multiply negative 3 in. So it becomes negative 3x, again negative 3h. And then I have positive 5. I multiply the negative sign in. It becomes negative 2x squared. Positive 3x, negative 5. And then I divide everything by h. h goes to 0. So still I am in the simplification process, yes? That's not the new lesson. That is just the lesson we learned in chapter 1, simplifying algebraic expressions. Yes. So here I multiply that, it becomes 2x squared. In the exam, if you do some of them in your head, that's okay for me, unless you make a mistake. That is, the risk is yours, yes? So 2h squared, and then I have minus 3x. We can simplify everything at the end. It doesn't matter. And then please watch my calculations as well. And h goes to 0. Okay. So 2x squared positive, negative 2x squared, cancel. Minus 3x, positive 3x, cancel. Positive 5, negative 5, cancel. So what is left for me? So let me write it here. So this becomes the limit of 4xh. That's it. But what do I have else? 2h squared minus 3h. Divided by h goes to 0. I hope that you know that you are not allowed to simplify in this form, but I can factor h out in the numerator. I will get 4x plus 2h minus 3, and then I divide it by h goes to 0. This h and that h are cancelled, so then it becomes the limit of 4x plus 2h minus 3, and h goes to 0. So what the answer is, I have to send h to 0, so 4x is left and minus 3. So it becomes 4x minus 3, so what you provided in as the answer is completely correct. So the answer is 4x minus 3. Now, if you can calculate this one for me, now if I ask you, what is g prime of 5, what is the answer? Can you tell me? What is the answer of g prime 5? So it means that I am sending 5 to this new machine. So it becomes 4 times 5 minus 3, 17.
Yes.
And if I change my mind, you don't have any problems anymore. So what's that?
Minus 3.
Minus 3. You can answer all of them. Yes? So if you do it one by one, that is okay. If you are interested just in one particular number, that's okay. You can just start with that particular number. But if you want to find a formula for every number, you have to do it in this a little bit longer way. But then at least you are relieved because you can answer all those questions instantaneously. Yes?
Is there a general formula for every derivative?
Yeah, that is actually a very long lesson that we want to talk about this. So then I don't want to start it today, but I want you to know that yes, the main part of this chapter is to think about in this way.
Okay.
Yes. Any questions here? Okay, so I think we have some parts of the book that you can study. I will go through them myself first to see which one is more suitable for you. But before leaving this lesson, I want to write 2 examples here. That is a little bit challenging, but I want you to solve it if possible, okay? So, this is a little bit challenging. Of course, I will teach you this. I don't expect you to be able to solve that. But let me write f of x equals to square root of x. Yes? And then I want you to calculate f prime of 4. Or if you are a little bit ambitious, you can also calculate f prime of x. Okay? So that I recommend you. I don't expect you to be able to solve that, but at least give it a try. You can feel where the problem lies. So it would be a little bit technical to calculate the limit involved in this case. Okay? Try to see if you can discover it yourself, or you can read it on Google or whatever on the net. But anyway, I want you to also, these examples are not in your book, but that is not above really the knowledge of your mathematics. So that is why I want you to think about this problem. The same problem, but for this function. Let us see what will happen. Any questions? Thank you.
Thank you.